Okay, so let's look at an example. So let S be the triangle with vertices at P0, which is 1, 2, 0, P1, which is 0, 6, 5, and P2, which is 7, 2, 9. Verifies Stokes' theorem when F is x, y in the I direction, x squared in the j direction, y in the k direction. So here is Stokes' theorem here. So the C is the boundary of S, and S here would be our triangular region. So we're going to show this side of Stokes' theorem first. So we're going to do the double integral side. Okay, so let me graph the triangular region here. Okay, so I graphed my triangular region. I didn't graph it accurately, it doesn't matter. I just put it up here, somewhat accurate I guess, but it doesn't have to be accurate. But it's actually in 3 dimensions, the triangle. So I just drawn it in a 2-dimensional board. Okay, so now we're going to have to find the mapping. We're going to transform this into a right triangle. So let's find the affine transformation that does that. Yes, we're going to find an affine transformation that maps this right triangle in the UV plane onto this triangle. This triangle is in the XYZ, so it's in 3 dimensions over here. So let's find this R mapping. So it's going to be an affine transformation. So let's write the definition of affine transformation here. Okay, so here's my definition of affine transformation. So it'll be A1U1 B1, A1U plus B1V plus C1, comma A2U, B2V, C2, and so forth. So let's make it so the 0, 0 point here goes to P0, the 1, 0 point here goes to P1, and the 0, 1 point goes to P2. So I could have made a different assignment. It wouldn't make any difference. It'd be a similar transformation. Won't affect the answer. So let's go through now and find conditions on the A's, B's, and C's. Okay, so let's look at the first one here. So the first one we have 0 for U, 0 for V, here, 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 all the way across. So doing that here, we'll get then, this. So putting 0 in place of U and V, you just have a C1 in the first component, C2 in the second one, C3 in third one. That has to equal the point 1, 2, 0. It means that C1 needs to be 1, C2 needs to be 2, and C3 needs to be 0. So C1 is 1, C2 is 2, C3 is 0. Okay, so let's replace those up here now. So I'll replace my C1 now with 1 here, my C2 with 2, and my C3 with 0. Okay, let's keep going now. So going to the second get on here, you're going to put 1 in place of U, because 1's in the U position, 0 in place of V. So 1 will go in place of U here, 0 in place of V here, 1 in place of U, 0 in place of V, 1 in place of U, 0 in place of V across there. So let's do that. So doing that, we'll have, so putting 1 in place of U would be A1, no B's, and 1. So it'll be A1 plus 1. Then it'll be 1 here for U, so it'll be A2, 0 in place of V, nothing there, so plus 2. So it'll be A2 plus 2. And then 1 in place of U, A3, 0 in place of V, gone. So you'd have this. So A1 plus 1 has to equal 0. So solving for that, A1 would have to be negative 1. And then A2 plus 2 has to equal 6. So solving for that, A2 would have to be 4. And then A3 would have to be 5. Okay, so let me replace those now up here, here, and here. Okay, so I've replaced my A1, my A2, and A3. So lastly, let's go on to the R of 0, 1 now. So that's going to be 0 in place of U here, 1 in place of V all the way across. So 0, 1 all the way across here. So doing that, let me write down here. So doing that, so putting 0 in place of U, 1 in place of V, you'd have B1 plus 1 here. Then over here you'd have B2 plus 2. Here you have B3 plus 0. So B1 plus 1 has to equal 7, so solving for that, B1 has to be 6. B2 plus 2 has to be 2, that means B2 would be 0. And B3 would have to equal 9. So let me replace those up here now. Okay, so I replaced the B's up here. So my 6, 0, and 9. So now this is our mapping. So this is our parameterization of our S up here. Okay, so we're going to be using that now. So let me erase some things. So summarizing, we found our parameterization of the triangle, and here's our f that we're going to be working with. So we're looking at the double integral side of Stokes' theorem. So it's the flux of the curl of f across S, but that's going to equal then double integral over our D region of the curl composed with our RUV dotted with RU cross RV du dv. So let's find RU and RV. Okay. So RU, so derivative R respect to U, I claim is this. So if you look at the first component up here, derivative of negative U would be negative 1, and these are V and constants, so it'd be 0, so just be negative 1. I'm writing it as I notation. Then moving on to J component, which is the second component here. Derivative respect to U of 4U would be 4, so it'd be, and derivative of this guy respect to U would be 5, that'd be 0, so it'd be 5k. Let's do RV now, derivative respect to V. So RV, derivative of R respect to V, it'll be 6I because derivative of 6V would be 6, and that's a constant 0, that's a constant 0. And there's no V here, so it'll just be 0J, and derivative of 9V would be 9. Okay, so now let's do the cross product of these two things. So here's the definition of cross product. So let's do the I component, so we'll cover the I column, so it'll be 4 times 9 minus 5 times 0. Yeah, so we have 4 times 9 times 5 times 0, which I have here. Then moving on to J component, be negative 1 times 9 minus 5 times 6. Let me write it here with a minus sign in front. Okay, so we got that. And let's do the K1. So that'd be negative 1 times 0 minus 4 times 6. So let's do that. So I'll get this guy over here then. So then working these out, this will be 36I, this will be, if you check, will be 39J, and this will be minus 24K. So we get this then. So now what you do is the curl next. So let me move this up here, and then we'll start doing the curl in this area. Okay, so I move my RU cross RV up here. And here's my definition of curl right here. So it's the del operator, and then my f, components of my f function here, my f function's up here. So put it over here. So let's start doing this. So let's do the I component first. So it'll be the partial y operator acting on y minus partial z operator acting on x squared. So we'll get this then. So then we'll go on to the j component. The partial x operator acting on y, partial z operator acting on zy with a minus sign in front. So we get this. And lastly, let's do the k1. So the partial x operator acting on x squared minus partial y operator acting on zy. So let's write it here. So we'll get this then. So then working these out, well, the partial operator acting on y would just be 1. That'll be 0 there. Partial x operator acting on y would be 0. Partial z operator acting on zy, it would just be y. So it'd be like a minus y there. And partial x operator acting on x squared would be a 2x. And then minus partial y operator acting on zy would be minus z. So let's write our final answer down here. Okay, so this would be your curl right here. Okay, so now we're ready to start doing the double integral. Let me move this curl up here now. Okay, so now we're ready to do the double integral. Actually, I'm going to change this around and make this dv du here. Okay, so here's my D region over here. So I'm doing strips this way. So it's going to go, the V is going to go from 0 to minus u plus 1. So let me start filling this in now. Okay, so there's my limits. So it's going to be 0 to 1 on the u and 0 to 1 minus u on the V, because you're going strips this way. And that's the equation of that line right there. Okay, so now we're looking at the curl guy. We're not looking at the f, we're looking at the curl, so this guy here. And we're composing it with our RUV. So that's my x component, that's my y component, that's my z component. So it's going to be I, it's going to stay I. Y, but y now is 4u plus 2. Okay, so it'll be then plus 4u plus 2j, and then plus 2x. Now x is this whole thing here, so it'll be 2 times negative u plus 6v plus 1, and then minus z. Z will be 5u plus 9v. And this is all in the k direction. And this then is dotted with our RU cross RV, so there are 36 I plus 39 J minus 24K. Then we're going to go dV du. Okay, so let me simplify this inside part here. Okay, so simplifying this part will be negative 2u minus 5u, so it'll be minus 7u, then it'll be 12v minus 9v will be 3v, and plus 2. Okay, that'll be the k component. Now we're going to go 36 times 1, 39 times this, negative 24 times this, so let's do that. So doing that we get the here, after we did the dot product, so we're going to run 36 times 1, 39 times that guy, negative 24 times this guy. Now multiplying this out and combining like terms, I'll just give you the answer over here. You can double check, you can pause the video and do it yourself. So you get this after you multiply the stuff out over here, combine like terms. Now we can start integrating, so it'll be integral with respect to v, so it'll be 324 uv 72 v squared over 2, 66v, so let me write that over here. So we'll get this then. So I'm going to put the 1 minus u in place of v here, here, and here, and then putting the 0 in it disappears. So let's do that next. So doing that, putting the 1 minus u in place of v here, here, and here, we get this. Now I'm going to make a w substitution. I'm going to let w equal 1 minus u. Okay, so w is 1 minus u. That means u then, so moving the w over here, u over here, u would be 1 minus w, dw, du would be minus 1, so du would be minus dw. So now it makes that substitution up here now. Okay, so making that substitution, we get 324 times 1 minus w, that's in place of u, times my 1 minus u, which is w, minus 36, be w squared, and plus 66 w, then du is minus dw. Okay, and now w of 1, put a 1 here, it'd be 0, so this would be 0, and w of 0 would be 1. So I could turn those around and introduce a minus sign, and we'll cross off with that minus sign, so let's do that. So we get this then. I also multiply the 324 in. Okay, now I can combine the 324w with the 66. That'll give me 390w, and then combining the 324w squared with this guy here, that'll give me minus 360w squared, so let's do that. So we get this. Negative 360w, integral of negative 360w squared plus 390w. So integrating this then, it would be negative 360w cubed over 3. And this would be 390w over 2, but negative 360 over 3 would be negative 120, and this would be divided by 2 would be 195. So let's write that over here. So I get this, so negative 120w cubed plus 195w squared. So then it's just going to be negative 120 plus 195, which is 75. Alright, so that's our answer. So that's the one side of Stokes' theorem, the double integral side, done. So I'm going to leave it there. We'll do part 2 where we'll verify that the line integral gives us the same answer. So let's leave it there.